So in this one, I'm going to now also add the images. But before I start, I want to show you what happens if you want to use like the same imaging practices for different operating systems and different like root file systems or other partitions. So on our previous ones, from like the RISC-V and also the long arc examples, these were the sizes of the images that we have. Like there is the sparse image size that is observable by du-sh, and that's like the command line that I did here. And there, in addition to it, there is also sorry, this is the command line. In addition to it, there is like ls-lh, which would give, even like if it's like a sparse empty file, and obviously the du would be 0 bytes, then this would be, you know, whatever you gave it like as the count in the bytes. So for the file system itself, I added also a place like for the overhead for the metadata, for managing the inodes and so on. And this is the size. So for the installer, which includes both the file systems, other file systems, the bootloader, the RAM disk, the rootfs, the kernel, and also some extra place for data, and also extra place for state management partitions, and also extra space for extracting OTA, and also having like a tarball for recovery, then you need much more space. So this includes like this 4.7 gigs. It actually includes also like this tarball that I think was like a 1 something gigs, and like this image itself. Okay. Now, since I have AB for the image, if it was like 3 gigs, then I need to have at least 3 gigs, okay? So I think that here I put like for each bank, AB bank of system, like 4 gigs, and then for extracting everything, we also need like to have enough space, not only for these 3 or 4 gigs, but also for more partitions. So there is the partition layout that I believe you already saw, and adding to all this per architecture, like the storage, if I keep it aside, would be this big. It could be 16 gigs. I could also like reduce it. So storage can become an issue, which is, by the way, why I've been reusing the images all the time, other than wanting to be like very specific. Now, let's say that I want to continue my previous video where I built busybox in the kernel for every platform. I showed you that the busybox platform, it's only like 2.4 megabytes maybe, and also because I put there like audio resources and statically linked DOSFS utils and E2FS progs for formatting for the disks, for tunables and so on, then obviously with these numbers I only need a fraction of it. So here's what I'm going to do. I'm going to now add to the previous build and also do the images, okay? So we'll start slow. This is a copy paste of what the numbers, okay? And some configuration variables that would affect the partition sizes. I will not be calling this function right now. I'm ignoring it completely. But the default here would be that we'd have 2 partitions of 500 megs, another 1000 megs for the extracting of OTA contents, and recovery tarball. I put like a 1 gig and a quarter here. So overall we'll have like a much less than 16 or 18 gigabytes, but we also have much more than what we need for a root file system. Like I could divide it by 50, and I would still walk away with it happily, probably. For the RAM disk, for sure, it doesn't need like it has almost 0 overhead, the CPIO. But for like the ext file system that I use as the rootfs here, this is what I call like the rich OS, but the smallest would be like busyboxos or Alpine OS or something like that. It's small enough. So these are like the numbers. So I'm just going to build it again. This time I commented up the Debian ones, and I'll just build for all the arcs which I already have, with this time with the pack images and generate QEMU script equals true. So let's do that. Let's do that, but perhaps before starting, let's see some of the things that I've been saying before. So these are our images. Let me make it a little bit bigger. This is what we built in the last time. I told you it's like 2.5 megs. For ARM 1.6 megs. I mean, it's not bad, right? For i386, it's a little bit bigger, interesting. The ARM binaries are like super small here. Everything is stripped there. And for the 32-bit x86, the overhead compared like to the 64-bit, I mean, the difference is like nothing. So these are different sizes, but like the maximum here was 2 point something megs, so it's nothing. Now let's see what would happen in our other root file system. So here I have like also other Ubuntu systems that I built. We can see 140 megs without graphics or like audio. But what we did have here from the recent one is 1.7 gigs, 2.6 gigs, 2.4 gigs for like the root file system. So it's a lot, okay? 2.5 gigs, it's a lot. That's right. So if I build for all of this, yeah, I mean, I will sometimes have a storage problem even though I have like 4 terabytes. So I don't want to keep wasting disk space endlessly. Okay, let's just see what I have right now here. 896 gigs. So what I'm going to do is I'm going to build it, and I hope that I don't have a bug here. So let's go ahead, let's see. So I'll do the wrapper all arcs. And I will build. So this time I will not, wait too much for it. I'll just pause the video. But we can see here that it's compressing the files and so on. This process can take some time, especially if it's like a big image. Okay, so it's building for several architectures. Now it's like for long arc. That's the last one, and it was done. So now it's been a couple of minutes for several architectures. And now we can go ahead and run one or most of them. But before doing so, let's see what is the difference in the image sizes. So I ran the same command here, and I ran it here. And we see that the output is of course the same. And for the images, the installer and the storage images, these were the sizes before. They're pretty huge. And these are the sizes now. I still didn't build for each platform separately. I was going to do it last night, and I just went to sleep, and I will just fix it now, but it doesn't matter. I have one example which is more than what I need. So look at the sizes here, like the system image, because like we took, it would be like the RAM disk size here, and then add the file system data and then some overhead. So less than 10 megs, okay? And the live CD itself, which is exactly the system image. This is what I did in this construct. If we make like a live CD, I just put a system image to see everything is good without like the overlays. So if you want to test everything together, don't make writable overlays, put them in the system image or overlay it on top of the system image. And the installer itself, I gave it like by parameter, like this size, so this is why it's like this. And the storage has the calculations of everything that I showed you before, like with this partition table. So it would be a combination of this. This function was never called, but this is the combination of it, okay? So I will very quickly just boot the latest one without any parameters now. I did some refactoring. I mean, I'm testing it with you, so I'm running it. This is the long arc uses EFI, the other architectures don't. It boots, and it's fine. So it also plays some sounds, that's great. Forget about OTA logic, about whatever. I want to see the kernel version. That's what I want to see. Proc version, and it's long arc, and it's what we wanted to have. Let's look at the block ID. Yeah, PscG install. So what's the thing here? Even though we do have another file. By the way, sometimes, yeah, it doesn't contain a partition table. Okay, so it's fine. These errors, it says, hey, it cannot mount playable system because the disk is empty. So I'm going to do wait for command line equals wait for removable media. I also need to do a only installer. This is because I put like DRM parameter here. And yeah, so I mean, forget about this. It's not like a real error. This is like for the first time, and then you say, oh, no worries, there is nothing, then I'll do installer A only. So it installs it right now. This is the long arc. It would be faster if it would be something else. It plays this amazing South Park song, very cheerful. I don't know if you could hear it. And yeah, I mean, I'll just go ahead, run it again. I haven't run busyboxos in a while. Now without the removable media. Now it's without the Debian. It's very important, okay? And it boots here, and everything is nice, and everyone is happy, and this is amazing, and this is so nice, right? So that's like what we have here, which is pretty nice, okay? So under temp log, I have like my init log, we're fine. And we have a magnificent root file system, okay, that it's pretty much, sorry, it's not this one, that is hardly used, and I had like 500 megs here. Now, since I know that it has almost nothing, I can easily go ahead and shrink it, and this strategy can help me if I'm trying to debug, trying to make installer, trying to build for several architectures. You don't need to do like the for loop like I did and build for everything. You can do for much less. So the idea is that if you do this, first try to first work on one. Then don't be greedy. But once you do that, then you can save a lot of time, because if you don't need to compress, I don't know, 4 gigs, then it's much nicer for me. So what I'm going to do now, I'm going to take this and I am going, instead of 500, I'm going to give it 10. All right, that's what I'm going to do. So that's for the system. For the OTA extract, I'll give it 100. Okay. Data, yeah, sure, why not? Overlay, whatever, but I'll give it even less. Let's give it 100 megs. And for the recovery, let's give it 200, although I'm pretty sure I don't need it. So I will now actually remove this thing, because we're after the first demonstration. And I will set the partition layout variable. I'll uncomment it. Okay. I needed to take care of this, but I didn't. And I also wanted to go and give it arc specific, but I also didn't. So let's do it now. This is why everything was the same. So, in my opinion, I think this is what I should have done. I'm actually not 100% sure. And let's do this. If it works, it works. If it doesn't work, it doesn't work. I'll fix it like in a second. And let's build. So I'll do this wrapper all arcs again. And of course, there is a bug. So I'll give it the current arc. Again, I don't guarantee that the names will be the same when you see it, but it doesn't matter. I teach understanding, and if you watch this without having, worked with me or been through my courses, then you might not understand what is like my way of working. I think that everybody teaches themselves, but I give the tools. So this is how I work, this is how I've led the people who report to me, and this is how I hope that I add effect on the people who I have taught. And I'm pretty sure that more than 10,000 people have taken courses with me. Face to face, virtual, who knows? Who knows how many people saw what, okay? So now we have like these nice things here, and we do have some interim data, so let's look at them. Like speaking of like the image sizes. So I did not touch the installer yet. I mean, it's hard coded in one of the other scripts that I touched. You will definitely not hard code it, okay? I just chose to do it because I wanted to put all kind of things in the CD. The removable media, nobody uses CD. So, but look at the differences. Like before, like the storage image was 5.4, now it's a fraction of it, and also because I was quite generous. So let's see how that works. I mean, I could just go ahead and take like one of those, and I'm pretty sure that the installer image file name was already created. Hey, by the way, we have here like creating installer image of blah 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 bytes. That's fine. busybox does not like sparse file systems in some ways, so it definitely doesn't like sparse tarbles, and this is why some of the images have been made as not sparse. That's the trade-off of adding more executable to busybox in the PscG embedded Linux training, than instead of like using in my reference file system everything statically, which of course helps to save a lot of problem headaches. Then some of the exercises would be using all kinds of other libraries. So it's not only in the embedded Linux, it's also on the Android internals, courses, but it's a long story. I mean, most of the courses are no longer for the public audience, so even myself, I don't remember what exactly is in which course, and I wrote everything. So yeah, okay. So we're done. Yeah, we'll do the latest thing again. But let's just see about the images here. Yeah, so I will change it so that now that the images are like smaller, that every architecture will get its own installer. By the way, this is the way it is designed, but I don't even know what I did in the wrapper scripts there. So let's run the same thing, and let's see if now it installs properly. And if it installs properly, we can say, oh, awesome, amazing, we can shrink the image size even more. So there is no reason to not do that actually. And I showed you, just like as a recap, I showed you how you can go and what happened here. Yeah, so failed to extract. Oh, of course. So look what happens here. This wasn't planned, but it's actually very good. What happened is that the file system has, I built like the kernel, and I said, okay, no matter what the root file system is, I'm going to put the kernel modules over there, but it's so bloated. So essentially, because it's so bloated, then the modules, even they are compressed, and there are issues with some tools. With busybox, it cannot run ZST. So if I have something like this, I also need to reconfigure the kernel to not compress the kernel modules. Okay, this is recently this was recently added in kernel 6, I think, that the default of all kernel modules is to be compressed. So essentially what happens is that I have like this root file, this tarbles, and I just don't have enough space for it. So it's pretty bad, it's not so nice, and this is why I fail. But since we already saw things before, I don't see a reason to show it once again. But look at our like disk stats here. So system, it's 6 megs. Yes, I made it, I think 10 or 15 or I don't know what. I think I made it 10. But most of it is used, and the difference from 10 or like from 15 would be the metadata for the file system. So just so you see or know it, let's look like what it tried like to copy it, or like what is the problem here. So I'll go to temp, because temp has enough size, and I'll do make dir blah blah. Okay, and I will see what's happening in this 25.3 megabytes. What happens if I untar it? $37.3 megabytes. So I can reason from that if I change my file system sizes here, instead of 10 to 50, no, I'll add just in case here, because I actually don't need it, but if I need it like for a tarball, yeah, let's do it anyway. The recovery tarball will not be more than this, I think, but yeah, so this should work, and I will make it faster now. I mean, whoops. Like for the arcs, I'll just use long arc and that's it. So I'll comment this out. I'll just use the latest long arc. I don't need here even like this. I'll run the wrapper. It will take a little bit of time, but it's fine. And take a sip of coffee, enjoy life. Here is what brought us problem the previous time, the module. There is a solution for that in my build systems as well. Like we can say, hey, we don't want to install overlays, or we don't want to install modules, and then we're done. There is another solution, of course. We can do, hey, config modules false, and that's it. And then you don't have module. But this build system is a tool. Okay, see how fast it was? It was super fast. So now let's do the installation again. And now it was already partitioned, so it may want to, I mean, I think it's already partitioned. Yeah, so, okay, so maybe it was not. It was not yet because it didn't like take care of like the OTA state and stuff like that. Anyway, we're good. And we're done. And now everybody's happy. Let's just see that we were not lying. And I do have terminals for this also, like OpenVT and so on and so forth. But now we'll boot a rootfs that will have 50 megs, so we'll see less. Okay. And let's do df. You see 45.7 megs. So this can serve even if you're not like an embedded Linux practitioners. It can save you as a good explanation of what happens when you boot all kind of things. So I will close the video here, and I will just do one build per architecture, and that's it. So I will add something more just because it's going to be super short. The reason it built for everything is that I was calling a wrapper that was calling the wrapper, so I'll just comment out this build image version here. I will add other wrappers and other configuration variables. I think I already documented lots of them, but if not, you have the videos and you have the code. And now I'll run like the same thing I did before, which I just put like the long arc there, and it took like a minute. So let's put it there as well, and we will see that it creates different images, and then we will be able to deduce that we can just run like a wrapper script over all architectures, have different installers, and then work with each one of them separately. So here we can see that the image itself stating blah 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 is here, but it also puts like a tarball there per architectures. So we can definitely see that, and it's done here, and I can run it, and it will just work. And then it becomes like a decision of, okay, let's say that I have this, do I also want to separate like the storage or the live CD image? And this will be given as all kind of command line parameters. So, but the idea should be clear. This is what matters, and with this we can just recap it. I'll just get rid of that one. We'll build it again. We already know that it doesn't take too much time per architecture. I'll pause, resume, show you like the resulting. We'll be reusing like the storage image because this is something that I can super easily modify over QEMU. It's not a problem. Over QEMU parameters. So I'll do this for a couple of architectures. Actually, we can already search because we're done like for like the long arc. And here we can see that we have each one of them, but look at like the size. So it is your consideration to do that. And I wanted to stop video before, so I think this should be useful, and I hope you find it useful, that now that you learned also how to figure out and how to configure from command line parameters, image sizes, and also how to debug them when you did like a bad job and you only find out about it like in runtime perhaps. Again, objective is to be quick. Of course, we can add a lot of more verification during the build time, and I actually do that, and my students do that, and you can do that as well. But you will not see it in the first uploaded version. So thank you for watching.